Today is what? Friday, another day, and it's the first day of No Shave November. So gentlemen, throw away your razors and grow out your beards. And then ladies, you can grow beards too if you want. Okay? But by the end of November, we're going to be looking burly.
That's what you're going to do.
Yes, he did the year before. He did it my sophomore year.
Look at that.
Oh, no.
All right. Now, so this very soon, within less than a week. All right. Now, we're supposed to do what? Graph y equals 2 to the x power. So let's do that. Press on, new document, don't save. Graph. No. So y equals 2 to the power of x. Hit enter. Now, this should look familiar from 1.2. We've done exponential before. Okay? Now, can you sketch that? Yes. Now, real quick, do you think this line touches the axis right there?
Yes.
No.
No.
Here's how you know. Hit Control T. Okay. See how it gets smaller and smaller and smaller? It's super, super small, but it's still not touching 0. Do y'all remember the name of that line that it approaches, but it never touches? What's that line called? Starts with an A. We did this on the last unit. What's it called? Asymptote. Asymptote, right? Do you remember that word? Right? And I know people don't have phones out. All right, so now let's graph this. So draw your axes. Now it's going to hit at 1. It's going to get real close, and yeah, do your best. Okay, so that is your warm-up for today. You can go ahead and pass it to the front. Make sure your name is on it. Make sure your name is on it. And I, or Miss Marrero, will pick these up. All right, so let us get started passing out these notes. Myself or Mrs. Marrero will pass out 2.6 notes. Okay, so we're going to get started. Make sure you're following along. Okay, now, we already graphed y equals 2 to the power of x on the warm-up, right? And no one has headphones in. And no one's looking at a phone. No one's sleeping. Looking up here, right? So, from our warm-up, we graphed it right here. I already have my table. and it wants us to put these points down. So off to the left here, -2, comma, positive 0.25, 0.5, 1, 2, and 4. Let's write that down. Does everyone see how I'm getting the table? I graphed it and I hit Control-T. And now I want you to graph those points, right? So let's graph those points, right? So -2, 0.25 is barely above the axis, right there. -1, 0.5 is right about there. 0, 1, 1, 2, and 2, 4. Now, like we just said, it does not touch the axis, so when you're sketching this, make sure it gets close. It does not cross. Okay. It should look like that. So that's 2 to the power of x. And we're going to do the same thing with 1/2 to the power of x. So let's go to our calculator and type in 1/2 to the power of x. New document, don't save, graph. Y'all know how to put in 1/2 to the power of x, parentheses, control divide, 1 on top, 2 on the bottom. Go to the right twice, and then caret x. Now you tell me, how does 2 to the x compare to 1/2 x? It just flipped over basically, right? Very similar, just reflects over the y-axis. So once again, let's get the table, Control-T, and let's put these numbers in. So we have -2, 4, and then my y values are 2, 1, 0.5, and 0.25. So let's fill that in. And then I want you to graph those points. So let's do that. -2, 4, -1, 2, 0, 1, 1.5, and 2.25. Once again, when you graph this, it does not touch the axis. It just gets close to it. It approaches it. Do your best. Now you might remember there's names for these. One is called exponential growth. The other is exponential decay. Okay? So exponential growth increases as it goes to the right. So 2 to the power of x is exponential growth, because as we go to the right, it's going up, increasing. Exponential decay decreases as it goes to the right. So you always look from left to right like you're reading. Is it going up or is it going down? So obviously that 1/2 to the power of x is decreasing as it goes to the right. Okay. Now we need to talk about domain and range. Miss Monroe has a song.
Domain and range, domain and range. The x is domain, the y is range.
Yeah. Okay, so domain. Now looking at these graphs, do you think it goes forever to the left? It does. Look right here. Goes. Wait. Well, whatever. It goes forever to the left. And so over here it goes forever to the left. Now this looks like it's going up, but it's actually going forever to the right and up. So since it goes forever to the left and forever to the right, we're going to put negative infinity to positive infinity for our domain. So go ahead and write that with parentheses. Negative infinity to positive infinity. Now, range. I'll be impressed if someone can tell me what they think the range is. Negative infinity? No. It does not go down forever. Do you see how it doesn't cross that line? Not half infinity. 1. It goes below 1. It goes below 0.5. It goes lower than 0.25.
0.
Hey, now does it touch 0?
No.
So 0 is as far as it goes down without including it. So are we going to use a bracket or a parentheses?
Bracket.
Bracket includes it, so parentheses. So here's the deal. The furthest down it goes is close to 0, but without touching it. So put parentheses 0, comma, does it go up forever? Yeah. Okay, that's what the arrowhead is. So that's the quirk of this range. Okay, the domain goes forever left and right, right? But it goes from 0 up to infinity, not including 0, because that's again, the name of this line, I'm going to do it in blue. The name of this blue line, again, starts with an A. What do you call it? It's a what?
What?
Asymptote. Okay. So that brings us to our next point right here. What is the horizontal asymptote? Now, remember we did this on the last section. It's either x equals or y equals. Which one is horizontal? X equals or y equals? Y equals, okay? So in this case, y equals, what is the y value on this asymptote? 0. And when we get to doing the examples, the letter D is what's going to tell you what the number is for the asymptote. Okay? And these next two bullets, exponential graphs may have one x-intercept or none. And then the exponential graphs always have one y-intercept. Okay? So in these two graphs at the top, there's no x-intercept because it can't touch the asymptote. But if I shifted it down, it would have an x-intercept. And it always crosses the y-axis, so there's always one y-intercept. Does everyone have this down?
Yeah.
Yeah? So, still on the front page, does this look familiar?
Yeah.
Now, it's a little different, but, you know, we've had this before where we have A, and we have B, and we have C, and we have D, but what's new here? K. This is new. So A, as usual, is out front. B, as usual, is right in front of X. C is always inside, and C is a what? You a lie. And then D is always out there by itself. But K is what I call the base of the exponent. Okay, this is the base of the exponent. So that's new. What does K tell us? If it's what or what? Growth or decay. If K is less than 1, like 0.5, 1/3, well, that's decay. If it's greater than 1, like any number greater than 1, that'll be growth. So we're going to use that on the back. Let's do two examples together. Go ahead and flip that page. Now, first thing I want to do is label A, K, B, C, and D. So now I'm actually making y'all write them out. Okay? What is A? Who thinks A is 3? Now, that kind of makes sense because usually A is out front. But remember, K is the one right here. A is in front of K. So look at number 2. See how number 2 has a number in front of the base? Like this is in front of this? That's an A value right there. But number 1 actually has no A value in front of that 3. So there's no A. Or not 0. Basically A is 1, but what I'm going to say is don't worry about it. Okay? Because 3 is actually the K value. Okay? No pun intended. 3 is the base of that exponent. If there was a number in front of that 3, that would be the A value. Okay? Is there a B value? Is there a number in front of X? There's no B value. Don't worry about it. Is there a C value? So C inside the parentheses is, it says 1, but it's a lie. So it's going to be -1. And then letter D is 2. Okay? So we had a K, we had no B, we have a C, we have a D. All right, now, what I want to do is graph this thing after I get my horizontal asymptote. Okay, so first let's think about this. Is this exponential growth or decay? All you need to do is look at this K value. Is this greater than or less than 1? 3 is greater than 1, right? So that's going to be, yeah, growth. All right. Now, horizontal asymptote, we did this on the front. Is it X equals or Y equals? What do y'all think? X equals or Y equals? Okay. It is Y equals. If I'll show you on the front right here, remember? Y equals, right? Okay, so Y equals what? So here's how you tell. It's not always 0. If it shifts up or down, that's going to change your asymptote. So what you need to look at is this number. So if it goes up 2, then my asymptote is going to be at 2. So I'm telling you, to get your horizontal asymptote number, you look at letter D. Okay? Let's graph that asymptote. So on the y-axis, I'm going to find the number 2 and put a point there. And then make a horizontal dashed line. That's the line I can't cross. That's the line I can't touch. Can't touch this. Now, let's graph this. We're going to go to our calculator, type it in, press Control-T, and get a table so we can plot some points, okay? Let's do that. New document, don't save, graph. Okay, so 3 to the power of x plus 1. So I'm going to press 3, caret, x plus 1, then go to the right, plus 2. Make sure you go to the right when you do that, otherwise it'll be in the exponent still. All right, so you see how that looks? I don't want you to make a random sketch. I want you to plot some points this time. So how do we get points? Control-T. Now, some of these numbers are too big to graph, so let's go down to some smaller numbers like, here we go. Let's plot these two. So -1, 3, 0, 5. -1, 3, 0, 5. Through those 2 points, I want you to make a graph that looks like that. So it starts going down, and it doesn't touch that line. It gets close, but it doesn't touch. Okay. And make sure you got these points where I can see them, right? And it doesn't touch this line. Okay. So make sure that red line don't touch the blue line. And you got those points on there. What do we know about domain? Goes forever to the left, goes forever to the right. So what am I going to put? -infinity to +infinity. Now this time my range is going to change. Ooh, that rhymed. So the range is not starting at 0 because it got bumped up to 2, right? So how far down does it go? Huh? It's not 0 this time, it's what? What do you think? What do you think? 2, okay? So I'm going to put parentheses, and I'm going to put 2. That's as far down as it goes. And then it goes up forever. So starting at 2, up to infinity, right? And we're on the back side. Yeah. So 2, comma, infinity, parentheses on both sides. Now, let's talk about those transformations. I got no A. Don't worry about A. K is 3, but I already talked about K over here, right? So don't worry about K. When you're doing the transformations, you're just talking about A, B, C, and D. So there's no A, there's no B. So C shifts left or right. To the left. Remember, plus 1 is a liar, so that's left 1. And then if the D is plus 2, letter D, it's going to go up 2. Okay, I'll give you a second to write that down so we can get to number 2 and be done with these notes, okay? If you already got that down, label A, B, C, and D and K on number 2. All right, so I'm going to label A, B, C, D, and K. So we already said A is negative 2. 1/2 is my K. This 3 is actually B. If there's no C value, C is 0. And then we got letter D over here. Okay? So let's write that in. Negative 2, 1/2, 3, 0, and negative 1. Let's see how smart y'all are. Who thinks they know if it's exponential growth or decay? Decay? Why? Well, not negative. It's because K is what? Less than 1. Half is less than 1, right? So since that's less than 1, it is decay. So all that means is it's going to flip around from the last one. Okay, and then horizontal asymptote, again, I'm going to look for the letter D in my equation, and it's always y equals, and in this case it's negative 1, right? That's my D value. So let's graph that horizontal asymptote, right? So let's put a point on the y-axis at negative 1 and make a horizontal line that's dashed. Before I do domain and range, let's talk about graphing it. Again, let's go to the calculator to graph it so we can get some points, make a nice looking graph that's on the right side of the asymptote. So on your document, don't save, graph, okay. So negative 2 out front, parentheses, control divide, 1/2, caret, and then we're going to have 3x in the exponent. Go to the right, and then we have -1. Now that's a lot, and it looks kind of weird because it's all stretched out, but that's it. So we got negative 2, 1/2, 3x in the exponent, -1 after it. Hit enter. Does everyone see that the graph is below the asymptote? Okay, it's on the bottom. That's because our K value, it's because our A value has a negative right there. Well, whatever. -2, right? It flips it over the x-axis. So let's get some points here. Control T. And the best points I have are maybe these two. 0, -3, and 1, -1.25. So 0, -3, 1, -1.25. And I want you to do your best sketch through those 2 points to make it look like the graph that we were just looking at. So make it look like this through those 2 points. So again, through this, well, I'll graph it first. And again, it's not supposed to touch it, so it gets close, but it doesn't touch. So again, you got these points, and it doesn't touch this line. Okay. Who knows the domain and range? Don't make Miss Burrow sing the song again. Who wants to hear it? Okay. Negative infinity to positive infinity. And then the range. Now, this is different. Is everyone listening? Is everybody listening? Since it's flipped over, you've got to think bottom to top. How far down is this going to go? Forever, right? So this time it starts with negative infinity. And how far up is it trying to get to? It's trying to get up here to -1. So you can write -1, but it doesn't touch because it's an asymptote. So we're going to write a parentheses. Okay, and last but not least, transformations. Start with A. If A is negative, okay, so this is on the front of your notes, but if A is negative, that means what? Reflect over X. And that's why it's on the bottom, right? All right, and then don't worry about K, because remember, K has to do with this, and this has to do with A, B, C, and D. All right, so reflect over X. Now, if A, again, the A value is negative, we already did that. If A is 2, 2 is greater than 1, right? When A is greater than 1, that's a vertical stretch. Vert, stretch. Now, next, B is 3. 3 is greater than 1. When B is greater than 1, that's a horizontal compress. Horizontal compress. I know this is a lot. Last but not least, C doesn't move left or right. Letter D tells us it's going to go up or down. Down 1. Okay? So make sure you got all that down. We're going to pass out 2.6. You may not, I don't think anyone's going to finish today, but you have Monday to finish 2.6. Our test on this is next Friday, so there's plenty of time to get 2.1 through 2.6 turned in, but we need to be working on these assignments, okay? Let's do this.